Good morning. My name is Ethan. I am an educator here for the Artesian Alliance, which is the Cheehaw Park and Zoo, the Thronatisca Heritage Center, and the Flint River Aquarium. And I'm coming at you today from the Cheehaw Park and Zoo. And we are going to talk about erosion and water and how those two are related to each other. So let's dive right in. I made a PowerPoint here. Present. So water and erosion. Let's talk about water here. Water is something that is necessary for life. It exists. It covers more than something like 80% of our planet here is covered in water. So that would be mostly oceans, lakes, streams, rivers, things like that. So much of our planet and all of our plants rely on water. All of our animals rely on water. Water is so essential and vital to our planet. Um, and it also completely shapes our planet and how it is shaped. So let's define what erosion is here. So one of the ways that water shapes our planet, in fact, the major way that water shapes our planet is through a process known as erosion. Um, Erosion is caused by three things mainly: wind, water, and ice. Um, so wind actually is what's causing over here. This is called the wave. It's in Arizona. It's a rock formation in northern Arizona, and that is all caused by wind. So those bands of rock there that you see, that's caused by wind. Oops, just move forward here. That's caused by wind. Um, so wind erodes away rock. What happens is wind picks up things like sand particles and dirt and other stuff, and it just beats away at the rock, slowly etching it out and etching it away. And erosion is that process of being just slowly worn away. And then another process of erosion is water. And what we actually have here is Providence Canyon, which is here in Georgia. We're going to talk about that one a little bit more, but Providence Canyon was formed by water erosion. So I have a bunch of photos. Some of them I took and some of them I found online, but there are a bunch of things, a bunch of results of erosion. So for instance, this right here is one of the arches in Arches National Park in Utah. And these arches were formed by a combination of wind and water. So Arches National Park is out in the middle of a desert. It's in the Great Basin. It's out in the middle of a desert. There's quite frankly no water to really be had around it. But all of these arches are found around there, all of these natural stone arches, and they're a very cool formation. And what they're caused by is they're caused by wind patterns just beating sand against it, like I mentioned, and also by water. You'll find very similar formations out by the ocean, very similar looking rock structures, and that's because they're caused by almost the exact same process. It's just kind of weird because one's out in the desert and one's right against the ocean, but water and wind tend to carve these out. Another example of wind erosion is this image that I took 2 years ago of the Badlands. The Badlands are in South Dakota. And what it is it's just this huge section of soil that is slowly being etched away on the water. So by water and wind. So this is mostly wind, and actually the Badlands move. Every single one of these peaks is going to look slightly different, even now than it did whenever I took this photo in 2019, because the wind has already changed the way that the landscape looks. The Badlands are kind of just this big carving out on the edge of the prairie here, And what happens is they are slowly receding because of all of the wind and the rain that is beating down upon them. So they actually lose as much as 1 to 2 inches of soil just right off the top of them every single year. So imagine this. This is the point right here, but then it loses an inch or two, and then it loses an inch or two, and then it loses an inch or two, and eventually, slowly over time, after say 10 years, it doesn't even look the same anymore, does it? That's because of just how fast wind is moving here. Um, so wind and water is moving. So this is Providence Canyon. This is a little bit closer to home. This is right here in central Georgia. Providence Canyon is this very large canyon that looks very impressive. It reminds you of things like the Grand Canyon. And the reason why, and it didn't exist 200 years ago. Didn't exist. There was no canyon here. Instead, there was forest. And what happened was a bunch of farmers came into the area and they said, man, we really want to use this area for farming. And so they cleared all of the land. They used the timber and lumber to build houses and build their industry. And then they tilled the land and made farms out of it. But this land was being held together by the roots of all of these trees and shrubs and other plant materials here. And so they, over the time, this canyon just started to form. In fact, by the end of the 1800s, it was already a couple feet deep, and then it just over the next several decades just really cascaded into this thing that we see here, this canyon. And so quite literally within one lifetime this canyon was formed, and it continues to grow today. It actually is still growing, though we're trying to slow it down and prevent its growth because this canyon is very unnatural. It's not supposed to be here, but it is anyways. And it's actually called the Grand Canyon of Georgia, mostly because of just the way that it looks. And it was just caused by water running off. And what happens is this water was running off in very specific ways, and it was just because of the way that these farmers were tilling the land, and because of how much land that they had picked up all at once with no regard for the water flow. The water was just digging these huge trenches into the middle of their farmland, and after a couple decades, it turned into this huge canyon. So this is Yellowstone National Park. This is another example of exactly the same thing we just saw here. So this is what Providence Canyon looks like after, 150 years of canyons forming. This is what a couple tens of thousands will do. So this is absolutely massive. It's kind of hard to give a sense of scale in this photo, but these trees are full-size trees, and they're the exact same size over here as they are right here. So maybe that gives a little bit of perspective how absolutely huge this is. This is called the Grand Canyon of Yellowstone because it is also absolutely massive. And as you can see, it's being carved out by the Yellowstone River right here in the middle. And so it's creating this absolutely massive canyon by just slowly over time, the water happens because of rain, because of streams, because of little runoff springs and stuff like that, is just eating away at all of this rock, and it's all channeling down into this one single point that's known as a watershed. And so all of this water is being tunneled in. Now this is a natural process. Unlike Providence Canyon, this occurred naturally over years and years and years and years. And it's still occurring now. But we've got to be really careful because these sort of things could end up accelerating into a massive Providence Canyon situation if we're not careful with how we interact with canyons like that. So I just mentioned the fact that the Yellowstone River, by the way, Yellowstone's right here, barely not on this map of the Mississippi River Basin. But I mentioned that the Yellowstone River is carving this huge canyon out over millions of years. Rivers are probably the #1 cause of erosion. There are so many rivers in the world, absolutely tons and tons and tons of them. And these rivers flow into these huge river basins. And so just imagine if Providence Canyon could do that huge canyon in just a couple decades, and the Yellowstone River could carve that huge canyon in only a couple thousand years. How much soil is being moved through something like, say, the Mississippi River, which is our largest river in the United States. The Mississippi River is this whole river right here in the center. It's this guy right here that runs all the way down from up here in Minnesota all the way down here into Louisiana. Some parts of Georgia are even in the Mississippi River watershed, like all the way up here. And so it covers like more than half of the United States, the Mississippi River Basin. Stuff that happens anywhere within this big blob that I have here. Any water that's in that huge blob potentially ends up in the Mississippi River. So if any water ends up in it, so does any soil that water is carrying, and so does any pollutants that water is carrying, and anything else like that. So the Mississippi River channels a ton of soil. In fact, more than a ton of soil. It channels about 500 million tons of soil into the Gulf of Mexico annually. 500 million tons. That's too big of a number to even really process. 500 million tons is so much stuff for it to be moving. It kind of blows my mind. So there's a ton of stuff being moved through the Mississippi River, and every single smaller river on here is contributing. Down here where we are in Albany, we get the Flint River Basin. We're in the Flint River watershed, so everything that happens here, all of the water and all of the sediment eventually is going to make its way into the Flint River and get carried downstream. All of these things contribute to erosion. So if there's so much erosion happening, why isn't all of our soil gone? Might be a question that you have. The answer is because it replenishes itself. There's tons of systems in place where soil might get taken from all the way up at the top of hills and mountains and stuff, and it's slowly carried all the way down into these huge plains, and some of it gets deposited along the way, and some of it keeps going, and these rivers pull all of this soil and it ends up in the ocean. But once it ends up in the ocean, it actually gets picked up and a lot of it gets pushed back onto the land, and it forms things called barrier islands, which eventually roll themselves back into the actual mainland itself, because barrier islands are always moving. It becomes our beach, and our beach is constantly moving. Actually, if you go to a beach one day and then you go to the beach the next day, you're probably not on the same beach technically. You're just in the same spot. The beach has actually moved all the way up. You're on whatever was down current of yesterday's beach. You're there instead. It's just you're in the same spot because the beach is always moving. So this constant movement of soil technically replenishes itself. A lot of this soil will get deposited in things like marshlands. It's why Louisiana, the end of the Mississippi River, is such a swamp. It's why southern Georgia has a lot of swampland to it. It's why all of these places near the coast tend to be very swampy. It's because a lot of soil just ends up there. right? And the soil will eventually build up and build up and build up and form new land masses. And then more soil will get piled up on top of that. It'd be like if you had a big old thing of cookie dough and you're just throwing more cookie dough on top of it and it's just slowly spreading. Um, that's kind of how our soil works whenever it gets deposited. So all of these systems are naturally replenishing themselves, and our entire continent is technically slowly shifting. So why do I have a dam up here? It's because dams are causing a really, really big problem. It's one that we didn't really think about whenever we put all of them up here. Water might move through a dam, through their pipes and tunnels, but you know what's not moving through that dam is soil. All of that soil that I just mentioned is moving and then replenishing itself in the natural cycle of things. That's not happening right now. Almost all major waterways in the United States are dammed at least once somewhere along the way. And these dams serve a very useful purpose. They help with our electricity. They help regulate where the water's going so we don't flood farmlands. They do all kinds of stuff. But the biggest drawback to dams is that they hold all of that soil back. So there's tons of soil being held back inside of dams. And so that soil is not getting deposited downstream, and it's actually quickening erosion. Because normally the river would kind of deposit some soil and take some soil, and it might be taking more soil than it's depositing, but it's a very slow process, right? It's taking soil, it's giving soil, it's replenishing as it's taking. But because it has no soil to give anymore, it's just taking. So it's just taking all of this soil and running with it. So all of this soil is just not getting replenished. It's sitting inside of things like dams. This is the Hoover Dam, which is all the way out. It's on the border with Arizona and Nevada. The Hoover Dam is a major hydroelectric dam. Whenever it was built, it was the largest dam in the world by far. In fact, the dam that we used to dam up the water so that we could build the Hoover Dam in the first place was the largest dam in the world. And it was just a temporary dam. And then we built the Hoover Dam, and it was the most massive dam ever. And it provides electricity to a lot of places like Las Vegas, but it has a huge drawback, and it's just there is no soil moving down the Colorado River anymore. So there's and this isn't the only example. There's tons of examples of dams. There are dams all over the place, and all of them have the same problem, which is that they trap soil. And so this soil doesn't get to places like the beach. And so our beaches, because of stronger weather from things like hurricanes, we're getting more hurricanes now than we ever have. They're pulling all of this sand away from the beach. And normally this would be a natural process where they pull sand away, and then over time the beaches build up again, and then they pull sand away, and then over time the beaches build up again. But because the storms are happening more quickly, they're pulling a ton of sand off, and because we just aren't getting as much soil and sand from streams anymore, making their way all the way downstream because of all these dams, we're losing our beaches at an alarming rate. And so we have to do things like beach fills, which is what this image is right here, where they literally pump sand in from offshore and plant it, basically build an entirely new beach, because we're losing soil so fast. So erosion is actually happening really quickly, and it's causing a lot of problems. I've mentioned water and I've mentioned wind, but I haven't mentioned ice yet. So there's another process of erosion that's caused by ice. And I'm going to talk about it on the big scale, and I'm going to talk about it on the small scale here. On the big scale, you get things like glaciers. That's actually what's right in front of us. And so glaciers are these huge, basically rivers of ice that are extremely massive. This guy is over 200 feet tall, and he's actually over a mile wide. it's kind of hard to get the proper scale here, but this is the John Hopkins Glacier in Alaska. This was a photo that I took, and the John Hopkins Glacier is over a mile wide. We are several miles away from this glacier right now. If we were close to it, we'd be a tiny little speck. It would be impossible for me to give you a proper sense of scale without having something like, say, an ocean liner looking like a tiny little tugboat next to this glacier here. But these glaciers, what they do is they build on the tops of mountains, and then they just slowly push all of this soil and sediment down as they move because they are just so heavy. They're incredibly heavy, and they carry all of this dirt. Like, this is actually still part of the glacier right here. This is all glacier. This is rock, but this part's still glacier. And back here, you can see some white, but you can see how this glacier is very dirty. Like, this is all part of the glacier still. It continues on this way. They're just pushing all of this dirt and rock down into wherever it is the glacier deposits. In this case, it's a stream, but this is an example from Iceland. This is actually Vatnajökull, which is the largest glacier in Europe. It covers 13% of Iceland. Just like a whole chunk of Iceland is just this glacier. This doesn't even look like a glacier, does it? If I didn't tell you that this was a glacier, you probably wouldn't be able to tell because it just looks like a big pile of dirt. This is the moraine of a glacier. A moraine is the edge of a glacier. This is the edge of the glacier. It is absolutely massive. This thing also doesn't give it a good sense of scale. But it is absolutely huge. We're about a mile away from the glacier right now from this photo. And you can see how dark and dirty it looks. That's because it is just grabbing all of this stuff and pushing it down with it. Like a really, really big ice cube. And this is not a glacier, but this is the signs of a glacier. You can see it all over the place. Glaciers carve these huge bowl-shaped valleys. So this was all carved out by a glacier, by it just slowly moving downward by its own weight and just pushing everything else with it. So this is, you'll see these a lot in heavily mountainous areas. You can even see it in places like the Appalachians, like Great Smoky Mountain National Park actually has some bowl-shaped valleys that were caused by glaciers from a really long time ago. This one's a lot more recent. This was only from about 10,000 years ago. And actually, our entire Great Lakes system, if you've ever had to learn about the Great Lakes, they're up here. Like, this is Michigan. This is the northern part of Michigan. Over here is Ohio and Indiana and Pennsylvania, and New York is right here. And you've got Ontario right here. This is all Ontario, Canada. The Great Lakes were all carved out by this process of glaciation. These glaciers, these huge glaciers from the Ice Age, just carved like an ice cream scooping out ice cream, just carved these huge lakes into North America here. Now, on a much smaller scale, ice also causes things like potholes. What happens is ice actually expands. It's less dense than water. That's why it floats. So whenever water freezes, it tends to expand a little bit. And what happens is in more northern places than this, whenever it freezes over for the year, any water trapped underneath the road or inside of the road will expand and freeze. And whenever the next spring rolls around, it'll all break up and you'll get tons of potholes. So I've talked about erosion a lot here, how all of these processes, wind, water, and ice, are carving out these valleys, making rivers flow, moving soil around and replenishing some areas while taking from others, and how it's out of whack right now because of different processes like us building dams. More extreme weather is causing erosion at a faster rate. And also just poor management practices like the farmers at Providence Canyon. These farmers weren't intending to build a canyon, and they weren't thinking about the consequences of their actions. It just happened, right? Um, so how do we prevent it or reduce it? How do we keep bad erosion from happening? Not just the natural process, but this sort of extra amount of erosion that we're experiencing today. One of them is better building practices. So, like for instance, if you've ever been to the beach, you'll notice that all of the houses are built on stilts. That's not just to prevent hurricanes, but also to prevent destruction of the sand and soil underneath. These houses, whenever they're built right on the soil, tend to actually make the waves crash against them harder and the soil to get pulled away faster. More mindful farming techniques is another great one. So, like the Dust Bowl way back in the 20s happened because of bad farming practices. And it's the same reason why Providence Canyon formed. Whenever we farm, we need to make sure that we are not depleting the soil, causing erosion at a faster rate. So we should be planting things alongside our farms that help keep the soil together. Because a lot of soil is being held together by plants, and the plants in turn are taking the water and sucking it up through, and the soil's happy and the plants are happy. But whenever we farm, we till up the land and we make it a lot harder for these plants to take root, and we make it a lot easier for the soil to move and erode away. So that going back to that, planting new plants in clearings and areas without vegetation, just planting grass, planting wildflowers, planting anything that's native is an excellent way to keep roots, to make roots hold plants together. In other places, using things like large stones, mulch, pavement, even if you're going to be walking on it a lot, can cause a lot of things, erosive materials. Like if you're walking on a dirt path a ton, it's going to erode the dirt really fast. But if you put, say, limestone over it, or even you pave it down, it's going to erode a lot slower. If you're ever at places like, say, Providence Canyon, you can stay on trails and paved paths. And these are all examples of things, what's known as soft engineering versus hard engineering. So a hard engineering would be like building a rigid structure, whereas something like soft engineering is like planting new trees to keep the place together. So all of these are great examples of soft engineering, trying to work with the land instead of against it. Planting trees to prevent erosion instead of trying to build like a house right there in the middle and causing all of these problems. If you're going to build something, you should try to work with the land instead of against it. And another great way to reduce erosion is just to encourage conservation. A lot of animals actually work with the land to help replenish natural systems. And I actually want to share with you guys an example of an animal that helps to replenish nature right here so that I can talk about it. But it's going to take me a second to grab it. So hold on right there. So I have in my hands an alligator. Um, Alligators are extremely good for reducing erosion. And I know what you're thinking. How? Uh, Alligators build what's known as alligator holes. What they do is they dig these big holes in the mud, and they will fill them with water, and they essentially just make their own little homes. And you might think, how does that help with erosion? Aren't they digging things out? And didn't you just say that construction practices can be bad for erosion? Well, alligators do something really special with these alligator holes. They fill with water, and actually plants and other smaller critters will also start to arrive in these alligator holes. And these holes help to create basically a new wetland, just a brand new marsh. And marshes are actually as I mentioned before, areas where our soil tends to build up, and then our marshes turn into forests, and then the edges of the forests become marshlands, and it just continues and continues and continues. So as soil gets deposited, marshes tend to help hold all of that soil together and build new land out of this soil that's being eroded and moved by rivers. Alligators help with that process. They actually are extreme contributors to the building of wetlands so that new vegetation and new animals can move into areas. So these guys help drive the rebuilding of ecosystems, not actually the destruction of them. So alligators and other creatures like alligators can help us to better conserve our land. So by doing things as simple as taking care of our alligator populations, we actually can help to reduce erosion. And you can do that by doing things like not feeding them and pretty much just leaving them alone to do their work. Sometimes the best thing that we can do to help Mother Nature is to just leave it alone. And I think alligators are a great example of this. We talked about erosion and what causes it: wind, water, and ice. We talked about some of the natural processes that help to cause that actually make erosion not a bad thing. So rivers and streams and even things like glaciers will move soil from one place to another, but that soil doesn't disappear. It just grows in a new spot and disappears in an old spot. But because of some management practices that we have been doing, things like building dams and building farms and without any real care for the soil, our land is getting eroded faster than we're able to rebuild. There's a lot of challenges ahead of us related to erosion and prevention of erosion. But if we look towards Mother Nature and try to figure out ways that the natural world has been replenishing itself, and trying to mimic that with things like soft engineering practices, like planting trees and plants, instead of hard engineering practices where we're sort of working against Mother Nature, we can reduce erosion and even prevent it outright in some areas where we don't want it, and let it proceed naturally as it's supposed to in other areas. So I hope this talk on erosion was informative, and I thank you guys for coming, and I hope you have a good rest of your day. Bye.